Good morning, good afternoon, good evening, everyone. Welcome on the next Learn Grasshopper live session. Today, I'm really excited. We have amazing guests and amazing session about Python and structural code. Really topic that is close to my heart. Guys, can you hear me?
Yeah.
Sure.
Yes, so today we have Morten and Sverre. Just let us know in the comments if you can hear us and see the screen. We have already 150 people waiting, so don't worry, we are not starting yet. You haven't missed all the webinar. We will start in 4 minutes. Hello from Canada. All good? Yes, we can't. Oh my God, we have so many from Nambia. From Canada, from Poland, from Norway. And you guys, you're both from Norway. Where are you exactly based?
I'm in Oslo, and this is amazing.
It's already winter there, or it's not? It's still not.
We actually had a small taste of winter this weekend. Now it's a bit on the plus side again. So I guess it was slightly raining, and yeah, the weather isn't all that good.
What about West Coast, Sverre?
Yeah, much the same. Super cold, -degrees last week, but now it's back to just raining immensely for the past 3 days. So business as usual here.
Business as usual, Sverre.
So Morten and Sverre are structure engineers. Sverre is a PhD candidate. When is your defense?
Friday.
Friday. So
this
everyone who is here, please cross the fingers for Sverre on a Friday. And Morten, you already been in this defense process. You are already PhD structure engineer. When was your defense? Do you remember?
Yeah, that was October 6th in 2017. So already a couple of years ago. But it was, well, exciting days, Sverre. I mean, receiving the topic for the trial lecture, that's kind of a weight which is leaving your shoulders, isn't it?
Yeah, it is.
We have already comments on the chat. Good luck with your defense. And greetings from Australia. Come on, guys, Australia. It has to
cool.
be midnight. So yeah, cool. The whole world is watching that. So
This is so cool.
In 2.5 minutes, we will start our presentation. So get ready. I will share also a little bit question. Do you know Python? If you can just answer from one, you don't know Python, or maybe you think Python is a big snake. And 10 if you eat Python on breakfast. So if you are really Python user and expert, so just write. So we will also know, it will be cool to see your level, to adjust the level of presentation. So we will see if there will be just ones. So we have to take our level of our presentation down, and if it will be all tens, so we will have to adjust it. Okay, there are some answers. We have the first one, -20. Okay, that is an interesting one. Okay, but we have some 7, we have some 8. We have 10, high one, nice to see you. We have some Python experts, but I think we will try to adjust for everyone. So even experts will find something interesting, because we are going to talk about new libraries, but also for new beginners. Okay, we have lots of 1s, 4s, some starts. Okay, cool. Nice to see. If you are also on LinkedIn, please comment. I cannot see any LinkedIn comments, so please let us know. Okay, yeah, we have some people from LinkedIn as well watching us. Okay, so mostly I do not have, but I can just scroll it. Let's say average 4, 5, like in the middle. Yeah, I think so. That we have some 10s, we have some 1s. So yeah, we will start. We'll try to adjust for everyone. Okay, so 1 minute left. Let's prepare some coffee, tea, and water, and we will start shortly. So guys, you are both structure engineers working in Norwegian companies. So are you using Python every day? Or
yeah,
for what
much.
and for what are you using Python?
Pretty much everything. I mean, at the office, we do many of our structural calculations in Python, and we also automate most or many of our software also with Python. So construct smaller or larger pipelines, automating our design process.
Can you
Python is really...
can you imagine your life without Python as a structural engineer right now?
Not for the moment, no.
And you, Sverre?
Yeah, likewise. Not so much these days. It's more PowerPoint with my trial lecture, but I'm looking forward to getting back to Python.
Okay, cool. Okay, we have 4 p.m. Central European time, so let's get started. We are live on Facebook, LinkedIn, and YouTube. And as always, thanks for being here, supporting us to do more of these events and promote this way of working. If you can give a like, share, or subscribe, we will be really, really grateful. So today's our two guests, we have Sverre, Magnus Håkonsen, PhD candidate, already said he is going to defend his PhD at Friday. In addition to making his PhD, he's working as a senior structure engineer at Covey. And we have Morten. Hello, Morten. Nice to have you here for the first time. For those who are following Learn Grasshopper Live, are familiar with Sverre already. Morten is a first time at us. He is a PhD structure engineer and adjunct associate professor. Maybe you can explain what does it mean, adjunct of associate professor? What is the...
It means that my primary position is at Multiconsult in Oslo. That's where my main job is, and part of my job is also to be at the university in Trondheim. So about 20% of my time. So I'm kind of related to the university, kind of.
Yeah, so we have good mix of experience, both work as a structural engineers, but also connected with the university. Okay, so today's webinar is about 90 minutes. It will be, I promise, not more than 90 minutes. Guys have to work to do. So we are going to finish sharp at 3:30 Central European time. That will be Q&A after session. A session will be about 1 hour. So there will be after half an hour of questions. Only registered users will get all the materials. We are going to share Jupyter scripts, notebook, and Grasshopper file and the presentation. So scan this code or register. I also show it. If you haven't received any mail from me watching, for example, that on LinkedIn, so please register to get all the materials. And this recording will be available for 2 days. We'll afterwards maybe we'll decide to share it, but for now, it will be available for 2 days. And we are here organizing this session for you. We are not organizing this session for ourselves, because we met already several times and been discussing Python for structural engineers. So please interact on the chat and write your questions. So today, first of all, Morten is going to show how we can use his library, how that he was one of the creators of StructuralCodes, and how can be used for simplified design code check. And Sverre will show also how we can use Grasshopper for that. So we can combine Grasshopper and Python. Then he will also show auto-generate calculation reports in Jupyter. Really cool stuff. So now you can quit all boring stuff with the Word and Excel documentation. And now you can make your work much more faster. And at the end, I will also share easy steps to start learning programming in AEC. Among others, Grasshopper, Python, and C#. Okay, so let's go with the presentation. Morten, you can share your screen so we can start. And maybe you can introduce to work that you've been doing for StructuralCodes, because you've been one of the creators of the new Python library. Is it correct?
Yeah. How is my resolution here, Chris?
It's a little bit bigger than usual. Now it's perfect.
How about this?
Now it's perfect.
So
maybe
yeah,
you can make an introduction. What is StructuralCodes? Because it's something new, right? It's just pop up on internet like 1 month ago, something like in October, right?
Yeah. Let me give you a bit kind of a taste of the background here. So I'm Morten. I'm the convener of an FIB task group. So that's already a 3-letter abbreviation. FIB, that would be the International Concrete Association. And TG, that would be a task group. So we are task group 214. The name of this task group is open source software development in the FIB. So it's kind of in the nature of this task group to develop something in the open. Well, if we rewind backwards a bit, so we can go to the FIB symposium in 2022, I had the pleasure of giving a keynote there, or one of the keynotes, and I decided to challenge the FIB. So I said, what if the FIB started developing a Python library, collecting models from the FIB model code? Well, turns out I got the challenge back. And in October, the same year, we did the first commit on GitHub, where we...
That was quick. That was quick.
Yeah, quite quick. That's the initial commit. And on January 13th, the year after, we had our first online plenary meeting of the task group. And then followed kind of a couple of, or a year and a half, more or less, with 19 online group meetings, countless one-to-one discussions, about 40 pull requests, and with active contributors from Norway, Italy, Spain, and the Netherlands. And finally, September 19th this year, we released StructuralCodes version 001. So that was a huge milestone for the group. Basically, what the scope of StructuralCodes is, it's a Python, it's an open source library with Python code, and it contains the necessary building blocks for performing design of structures. So emphasizing then building blocks here. It contains functions that represent equations from design codes, classes that represent materials, for example, concrete and reinforcement, and classes that represent cross-sections with arbitrary shapes and arbitrary reinforcement layouts. So it provides quite some flexibility for the user. Since we are, or since the maintainers or developers now, we are based in Europe, and since the initiative comes from the FIB, we focus on concrete, we focus on Eurocode 2 and the FIB model code. However, the framework that we designed should be flexible enough to also fit other codes and other materials. So
and this is also our, and sorry to interrupt, I would like to add, this is also our aim of this webinar, also to inspire all of you that this kind of workflow can be reused for other codes, not only in Europe, but also in America and Asia. And even yesterday, we got a question from one of the professor from UK to make something similar to guide to make something for Eurocode 8 for steel. So we can see like this direction. So today, Martin is going to show what amazing stuff we can do with this workflow.
Yeah, that's a good point. And yeah, let me also briefly mention what's not the scope of StructuralCodes. So it's not the scope to calculate loads on structures, nor calculating the response of structures due to such loads, or to provide graphical user interfaces for design calculations. So basically, it's the building blocks that can help you create other tools that can do these kinds of things. So these aspects can be covered by something else built on top of StructuralCodes.
Mm-hmm.
Let me also emphasize that we do this in the open. So you can follow all our development on GitHub. So I will share a link in the chat afterwards. Here you can check out the milestones, our issues, and the open pull requests. You can, in our online documentation, you can find the contribution guidelines. So this will hint you in the direction of how to contribute. So please have a look there if you wish to contribute something. And also reach out to me on LinkedIn. So you can follow me on LinkedIn to get notified about updates. I post regularly there about updates and also features in StructuralCodes. So make sure you tap in there.
I posted on the chat a link to GitHub, and we will for sure, Morten will appreciate all the stars left on GitHub.
Yeah, sure. Yeah, you can count stars. So these links will take you to where the code lives and where to get updates.
Yeah, just it was one. Yeah, it was also the question if we are going to record this session. Yes, this session is will be recorded and shared with you on the email, and Morten also is going to send a PDF of this presentation, right? So you can also check it afterwards.
Sure, no problem.
Okay, so this is everything for free available, so everyone can download that and use it, right?
Yeah. And on that note, let's do some live coding, huh?
Perfect. So we can now see in practice how actually we can reuse these codes and what actually is that. So let's go to live coding.
Yeah, and I will get my terminal up and running here, and I will share my screen. So let's see if I can find this again.
Are we going to use Visual Studio?
Yeah. So what I will do now, I will from my terminal, I will briefly demonstrate how you install the StructuralCodes library. And
okay, so just explain what are we seeing right now?
I will, yeah. So what you see here now, this is a terminal window. I prefer to use on Windows. I prefer to use a Windows terminal. I like to use PowerShell, which is kind of this is where you interact with your system. You might get intimidated by seeing this terminal window, but this gives me at least control over what's happening. So this blinking vertical line tells you here you can type stuff. So what we will do, we will use Python Launcher. So py, that's on Windows. If you're on Unix, you typically would type Python 3 or something. If you're on Mac, it's the same. Here I'm using Python Launcher, so I'm addressing a specific Python version on my system, and I create a virtual environment. So creating a virtual environment to get this Python installing now isolated. So running this command creates a virtual environment that I can activate. So activating this kind of changes my prompt. From within this environment, I can install StructuralCodes. So here I'm using Py, which is the Python launcher. I use pip, which is the package manager for Python, and I'm installing StructuralCodes. So now it collects StructuralCodes from the internet and it installs it. We will also use a Jupyter notebook from within VS Code. For doing that, I will install ipykernel and nbformat, which are two libraries that are required for running this. I will share all these libraries.
No worries. Like one is asking, is it required a virtual environment to run it or not?
Thanks. That's a good question. It's not required, but it's always a benefit to work in a virtual environment because you can, if you run into issues, you can always ditch the environment and create a new one. So I always recommend that. But that's a good question. It's not required. And finally, we will install matplotlib because we're installing something. Now we are plotting in addition. So we'll do some plots as well.
So now you are installing on your Windows every single library that you would like to use and show us, right?
Exactly. So now we have installed StructuralCodes, matplotlib, and ipykernel and nbformat to use a Jupyter notebook within Visual Studio Code. So to open Visual Studio Code, I'm typing code and then dot, and I will share another window with you. So now Visual Studio Code, that's a code editor.
It's from Microsoft, right?
Yeah, it's open source. It's free. You can download and install this for free on your computer. It's, well, I prefer to use this. It has a really good interface with Python. You can work on Jupyter notebooks from inside this window. For sure, you have other popular tools as, for example, PyCharm, which is really popular. So often the race is between VS Code and PyCharm. What you see here now, make sure that you select the kernel, so the Jupyter kernel from the virtual environment that we just initiated and populated. And here you can see now that we have a cell that we can write code in. So we can do now from StructuralCodes, import set design code. This is a useful function for setting the active design code in your calculations. So let's now do a set design code AC2 2004. So now, inside this session, I told StructuralCodes that your code 2 from 2004 will be the active code that we're using. Next, we will create a couple of material classes. So we can do from structuralcodes.materials.concrete, import create concrete.
Just maybe we should also mention that there is also or the library is well documented. So all the formulas that Morten is writing is not just from his head. Actually, everything is documented. So you can, if you go line by line in the documentation, so you can find all the. And here's the link.
Yeah. So below here in the About window, you see the address to the documentation. So if you enter this and enter into API documentation or API reference, you'll find all these functions that I'm using here. So now we'll create a concrete. So create concrete. We will say that it has a cylinder strength of 40 megapascals. Now, this is a good entry point for all our calculations because the concrete class, it has, for example, attributes for Young's modulus, for tensile strength, for design cylinder strength, for example. And here we'll also recognize that we used FCK equals 45. The default value for gamma C, which is the partial factor for concrete, that's 1.5. So this value, 30, that's basically just 45 divided by 1.5. We also know that in the Eurocode, we have this alpha CC factor, which is defined in the national annexes. So at least in Norway, this should be 0.85. So make sure that you set this one correctly. So you see now that when I set this to 0.85, my FCD changed to 25.5. Furthermore, we can also access a constitutive law. So if you just type like this, we'll see that, okay, the constitutive law, that's a parabola rectangle object. We can even get the ultimate strains of this one. And now we can use, for example, NumPy, which is a library for doing numerical calculations in Python. So we can do import NumPy as NP. We can create an array of strings.
Also note for every beginners here that we have to import some libraries that make some more advanced calculations, like maths or NumPy here, and even pandas for more. So yeah, like be aware that Python has to be most of the functions have to be imported to Python itself.
Yeah, sure. So now we'll create a array of strings. So going from from the negative ultimate strain to 0. So, and let's say that we use 100 points. Next, we can calculate stresses corresponding to these. So we can use the constitutive law, so get stress method on the constitutive law based on the strains. And there you have the stresses. It would be nice to visualize this. So let's do as Chris said. Let's import matplotlib .pyplot as PLT. This is kind of the de facto standard for doing static plots in Python. So we can do create a figure and an axis object.
So every time we have to refer to this. So as you can see, like we have import matplot library and as PLT, and we have to refer to that one. And you can see nice graph.
So for sure, this is just out of the box graph. Here you have all the powers of matplotlib to change the labels, change the axis, change the limits of this, etc. We can change the resolution here, see how this plays out, and see what it turns into. We can even do a concrete dot constitutive law equals, for example, sargen to do another constitutive law, or just keep it like it was.
Mm-hmm.
How are we on time now, Chris?
Yeah, we can still we can just continue for 3-4 minutes, so we can pull some more. It was a question from Vladimir that we can answer. Is it possible to use the structure codes in the collab?
Yeah, sure. I haven't tested that much, but it's pip installable, so it should be it should be available. Yeah.
Today we are going to show different environments. So after Morten presentations, Sverre is going to share how it can be used outside Visual Code. So there are different environments that can be used structure codes. And what are we doing right now?
So now we are here. I'm importing a function for creating reinforcement as well, and I'm importing some ductility properties for reinforcement. So we will create a reinforcement object. So reinforce equals create reinforcement. So basically this will then do the same as the create concrete function here. Since we are a bit short in time, I will open a separate notebook here where I did something more. So here you see that we created this reinforcement object, just as with the create concrete object. In addition, we have defined some height and width of a cross section. We have defined some parameters controlling reinforcement bar diameters and some number of bars and the cover of the reinforcement. So now we can start thinking, well, we are going to draw a section. To be able to draw a section, we use the Shapely library, which comes with StructuralCodes. So here we draw a polygon based on 4 corner nodes, based on these 2 parameters that we just set.
So if users install StructuralCodes, so Shapely will be also installed with the same installation package?
Yeah. Yeah, so behind the scenes, we are using Shapely quite a bit. So from Shapely, import polygon. So this geometry, this polygon, we are using this inside a surface geometry class. So here we are referring to that polygon and the concrete material. Furthermore, we add reinforcement. So we use the add reinforcement line. Basically, this function takes a geometry object and some information about reinforcement. So we add reinforcement at the bottom and the top of the section. Let me just then demonstrate what this looks like. So for free now, you can just type reinforced surface, and then this figure pops up in your Jupyter notebook. So this is a SVG visualization of this here class. So here you can immediately see what you just created. Based on this, we can create a section. So a section is kind of an analysis tool, so a section analyzer. And we can calculate moment curvature for that section. So let's finalize with that. By calling this calculate moment curvature method, we get a result object with curvatures, moments, etc., that we can furthermore plot. So here you see a nice view of the moment curvature response. So moment on the vertical axis and curvature on the horizontal.
Yeah. And I think it's yeah, we can wrap it up, and yeah, it will be good also point to switch it to Sphere, because he's going to show us a little bit similar workflow.
Sure. So the final comment here is that on this section calculator class, so you can type section.section calculator, you will find more methods. So for example, calculate NM interaction domain, calculate NMM interaction domain, calculate MM interaction domain. So all these nice response calculation methods.
Mm-hmm.
Now I just demonstrated kind of going from the basic building block, which is the material classes, up to the section level. What I did not touch is kind of the other tools that are in the sphere of the design codes here. So we also have methods for calculating creep, shrinkage, and shear.
You can briefly, sorry for interrupting, we can briefly share it. So you said that is for shrinkage. What more?
Yeah, I figure I should just mention it. So you have functions for calculating creep, for shrinkage, transfer, shear, torsion, and stuff like that. For sure, we don't have 100% coverage yet for the design codes, but this is work in progress.
Perfect. We have some question to your work. So is it something that this example that you show, it can be also on the GitHub anytime? Because there is some of the example already on the website. What are the plans?
I must say the answer is yes. So there will definitely be more examples. So we should be able to anticipate a usage guide with examples going from the basics to the top, just as I did now, to kind of demonstrate the intent or the intention behind the API. And I would also anticipate examples related to the different code functions. So yeah.
And what about the units, and where can we see the units of the values?
That's a really good question. I appreciate that. So to be short, we're actually working on that right now. And to provide a bit more context, you will see that there's an open pull request that I'm working on, where we explore how we can handle units in the library. Basically, the section and the analysis algorithms that we have in there all work in consistent units. So meaning that if you provide your material with stresses and material stiffnesses in megapascals, and you model your geometry in millimeters, then you will get moments in Newton and millimeter, you will get forces in Newton, etc. Now we are working on a feature where you can kind of decide upfront which units to work in, and then the design process is more or less related to how much freedom will we implement, and how much kind of consistency would we like to impose on it? So it's just a delicate balance.
Yeah, it would be, like we have some comments. It will be good if the units can be handled the same way it's done in MATCAD. So just a suggestion. Cool. And we have the next question, and I think it will be good way to go to sphere representation, so we can share your screen. Can other shapes such as circular section and radial reinforcement can be added? And actually, Sphere is going to show some examples. So thank you, Morten, for your presentation.
Can I just add one thing to that question?
Yeah, sure.
Yeah, sure. Oh, great. Well, there's basically no limit to what you can model because we leverage Shapely on the back end here. So, but I mean, there might be a user threshold to get there. So that's why we are currently working on implementing wrappers for our geometry classes. So if you have a look at the open pull requests, you will see that we are working on a wrapper for rectangular sections and one for circular sections. So that's what we're currently busy with. And also, of course, circular arrangements of reinforcement. But yeah, there's no limit since we're using Shapely on the backend.
Cool. So yeah, thank you, Morten. There are still lots of questions, but don't worry, we have Q&A session and Morten is going to come back. So you have a pause right now, Morten. So can you take your free time? So let's go to sphere representation. So Sphere, you can share your screen. So let's jump on your presentation. So Sphere is going to show how structure codes can be used in different environments. Morten showed it in Visual Studio, and now let's jump. I know that it's a Learn Grasshopper live session, so of course we have to have Grasshopper in here, and that's why we have our expert Grasshopper and Python Sphere. So let's go to and show how we can use actually structure codes in Grasshopper and Rhino, because it looks like a cool thing to do.
Yeah, I'm just intrigued by watching Morten present. I think it's a really nice library, and as one of the questions mentioned, it's not that many examples so far. So it's really nice to see one of the key authors actually going through it instead of going through the source code for hours.
And I think it's just the beginning. I think if it will be like a snowing ball, like it will be more and more. So yeah, if faster jump on board with the Python and structure code, so it will be better for all the industry. Okay, so let's go to Grasshopper.
Yeah, so yeah, as Morten said, with the structural codes in Python being kind of the building blocks, which I believe is one of the beauties of Python and the open source community, is that now we can take that work and we can, for instance, use it in Grasshopper or in any other familiar environment that we like to work in. So just to show you or give you a minimum understanding of how we can do that, going from, for instance, drawing our sections in the Rhino viewport from polylines, if that were you're working, and into structural codes to get, for instance, here in this case, just some moment or bending moment capacities of a given cross-section. I will try to show you that. So the idea of this example is just to show that we can take the structural codes library and apply it, for instance, in Grasshopper and Rhino. So how this works is essentially that in this case, I have one layer where I draw my polyline cross-section, and I have one layer for my rebar, which are these points here. And I can just preview them in Grasshopper to make it a little bit easier to see. So as Morten was previewing it earlier in Visual Studio Code, of course, we can do the same here in Rhino, and we can change it. And if you see the values here of the cross section, if I move around here, I can kind of instantaneously draw different cross sections. I can add reinforcement. I can just copy those, and we get updated results like that. So I will just briefly show you how to set up this script, and I believe we will share it with them later, Chris, so they can have
it.
Everyone.
Everyone who registered will receive the presentation and the Jupyter script and the Grasshopper script, so we can reuse it as you wish.
Great. So first of all, if you're new to Grasshopper as well, I'm using these pipeline components, which are kind of the binding between geometry and Rhino and getting that into Grasshopper. So here I add one of those components. I add the name of the layer that I want to take geometry from. I can filter by the name of a specific object, or I can filter by type. So here I have curves. I want to take the curves. So if I drew any points there in the section now, in the section layer, I would not take them as well. And I do the same, of course, for the rebar, getting the points. So I have some curve here, and I have a list of points. And I also have an input for some different values of diameter of my longitudinal reinforcement, which also affects the capacities here.
So this is all the inputs that we have for our Python. And for those who are not familiar with Rhino 8, from Rhino 8 we have access to Python 3 and access to all the libraries. It was not possible to import all the libraries before. Now we have this possibility.
Yes, so that's the beauty of Python 3 or CPython. So if I open my script, I will not go through everything, but just as Morten installed StructuralCodes in his virtual environment, we need to install StructuralCodes in the environment that Rhino is packages in. So that's what I'm doing here at the first line, using this R:, which is short for requirements, and then I specify the packages that I want to use. So you can either do it like that, or you can go into the package manager on top here, and you can start typing here and press install, and you will get this line for your script as well. So if you share this with anyone, as long as this line is here, when they open the script, it will download the necessary packages for them to run the script as well. And then a small little feature of the Grasshopper script component here is this ability to message the component, just to make it easy to see what's actually going on. So that's just a line appearing here. So if I comment it out, still there.
Yeah, I think you have to open again, because it remembers from the previous session. But it's just easier. But it's easier just that it's showing like you can create lots of different components and have them for different purposes.
Yeah. So just when you have 5 of these, you know what they're doing. And then Morten showed very much of what we do here by importing, adding the reinforcement geometry. I will not spend too much time on that. But as Morten said, I set the design code here to Eurocode 2004. I have some concrete characteristic strength, and I'm also adding these national annex material parameters that may differ from country to country, and I add them to the material here. When I'm creating the concrete, I'm adding them as keyword arguments in this way. A little bit different from Morten, but the essence is the same, and I can check what there are here. So if I change this to 95, you can see here I'm changing the value by changing those parameters in my dictionary here. So there's 85. And then the difference between this script and what Morten showed is that we have as input, we have Grasshopper or Rhino geometry. So I have a polyline curve from Grasshopper and a list of points from Grasshopper. So I have to convert that into the data that Shapely and StructuralCode is taking. So the first thing I do, which of course this Shapely is working in a reference plane, and I'm drawing here in the world XY, and the origin of Shapely and this geometry here has to match. Otherwise, if I'm drawing around a centroid here and add a normal force, when I'm calculating the capacity, we will get an eccentricity between the centroid of the geometry and the application of the normal force, which will give some moments. So in order to be consistent, you see here now the capacity doesn't change if I'm moving my geometry in space here. So for the first thing I do is I find the centroid of my section, and then I'm just creating that vector, translating from the section of my section to the plane origin, which is where I want to create my Shapely or StructuralCodes section in. So I'm just moving it back. You don't see it here, but that's what's happening. So I can print it if you want to see the TVEC. Here, so this is the distance. I have to translate this geometry back
to zero, to origin, to 0 point, right?
Yeah, so if you see here, if I getting close to the origin, this will become smaller. Now it's bigger. So that's just to be consistent to avoid those eccentricities if I'm missing to draw the centroid around, especially if you're drawing something by freehand. If I start moving around these points, that can be quite difficult to find the centroid.
But we can already see that if you are changing profile, it's something new result, so it's working.
Yeah, it's working. I think it should be working. So yeah, and then when I'm done that, I have my section, still a Grasshopper polyline, but I have to transform it into this array of points, which I'm doing here. And then I take those. So you take the polyline, and from that you can have an array of points, which is a tuple of x, y, z coordinates, which is what the Shapely polygon is taking. So here I'm going from the Grasshopper polyline curve to a Shapely polygon, which is what I need to create this concrete section that Morten was creating previously as well. So from here we have this StructuralCode object. So you now see if I print my geometry, it's a StructuralCodes geometry, surface geometry class object. So now we've gone from Grasshopper to StructuralCodes for the section, and then I do the same for all my points. So here I have my list of points, and for each of those points, I take and add to the geometry using this add reinforcement function, which is also a StructuralCodes function. I add a coordinate. So again, this takes a tuple as an input. So I just take the x and y properties from this Grasshopper point object and create a tuple for this reinforcement object.
And in this point, I can also show one question, because I think it can be intriguing for lots of people and structure engineers working. Have you tried workflow importing cross-section and rebars from Revit with Rhino inside? I can answer that. I have tried with Tekla. Actually, I took cross-section for all the columns on one of the projects, and I will make a cross-section that automatically found a reinforcement diameter and the placement. And actually, yes, it is possible to do it with Rhino inside. And after you will think that you can work in this way, that actually you can go through automatically through your Revit model and make automatic cross-section and automate in this way, and then make a report. It's actually mind-blowing. It's really changed completely how I looked on the structure engineering. Sorry for that comment, but I had to add it that what we are showing, that for people can look like, okay, it's a simple like beam calculation that simple software can do. But if we take a global scale, how the structure codes can be used globally on the structure, it can really automate our work. But let's please continue. Maybe we can show the time is running. Maybe other section, right? That maybe you can just quickly show it.
Yeah. So again, creating the reinforcement, and then it's essentially what Morten did, adding that, creating the section calculator, and then I'm able to get the bending moment capacities for my section. So that's how it's working, and I will share it with you later. And I'm just calling it here. And I believe I can fix it later.
But maybe we can also show this example in Jupyter. Maybe it's go to let's jump into how to make the reports and another environment. So let's jump on it. So maybe also show a little bit how we also can make reports and make cool graphs.
Yeah. So again, taking structural code as the building block. Maybe you want to work in Grasshopper. Maybe you want to create reports. Maybe you want to just create a simple calculator. So I try to make a small example here for structural codes in Jupyter Lab with this mist markdown, which is great for producing reports, because if you try to share this native Python script language to your colleagues who doesn't know Python, they might be skeptical. But if you can put it into a little bit nicer user interface, it will be much easier to convince them to test it out, try it. So here again, I'm importing structural codes, and here I have this virtual environment here, which is the same as Morten created in Jupyter Lab. I have some requirements, which are the packages, just as we had on the top line of the Python script editor in Grasshopper. And I just import. So here I just use some functions from Matplotlib. I have NumPy. I have some widgets, which is how we can interact with the script without having to go into the Python code itself to set the variables, and also, of course, structural codes. So first, I create widgets, which are these kind of selectors. So if I run this, here you see, instead of having to set the variables, say here, for instance, I would set the rebar diameter, and then anyone seeing the script when I'm sharing it with them have to find this and go.
If you can just make it bigger, if you can just make it a little bit bigger, yeah, thanks.
And they have to go here and find that this is the rebar diameter, which is really confusing. If you don't know Python, we can create these widgets, which allow us to change the values or the variables in the script from a much more, say, intuitive user interface. So here I can set a concrete cross-section. I can set the width and height. I set the grade of it. I select the diameter of my rebars. I can set the stirrup diameter. I can set the cover 50, and I can preview that. So this is how it looks with those inputs. If I go down on the cover, I get an update here. Suddenly I can fit
with the one rebar. It's not that usual solution.
No, it's a little bit thin section, so I can bump it up again. This is one way of really just getting that kind of quirky coding natively here in Python into something much easier for some non-Pythonists to use and experience. And then we can provide information here on the width, the height, the grade, how much reinforcements we have. So that's one way of setting the cross-section. And then, of course, in the code here, afterwards, I create, just as Morten showed and I just showed in Grasshopper, so I will not go through it all again. But I'm taking the values from those widgets, using them to create the concrete material, the reinforcement. I'm creating my cross-section here based on the width and height properties of those widgets. And then I'm just here I'm using Matplotlib to plot it just to get the extra information. So if you want to share this in a report, you can also have it here, or you can put it inside, whatever. And then we can do some calculations. So here I just did this ultimate strength or ultimate limit state calculations. So I'm creating this MN interaction diagram. So I'll just run it again, I think. So here I can set some input forces. So I want to set, I have from my calculation global analysis for a given section, I have some compression force. Maybe I have some shear forces and a moment, say 68 kilonewton meters. I run that.
And so we can get a nice graph based on all the calculations that are from StructuralCodes. Yeah.
Yeah. So again, I can just calculate them in again using Python, and we could have the numbers, but we can also have and create this and diagram which shows us this interaction. So the possibilities. So if you're outside this line, of course, you have exceeded the capacity. So here I'm just plotting. For the given forces I input, we're here on the NM diagram. So for the given section, this will not change, but we can change and play around with the forces and see how it interacts. And again, if you're doing a report, it's much more informative to present it in this way instead of a simple, say, print statement at the bottom of a code cell like this.
It's just a matter of creating good template, right? A good template to send it to doc file, and you can just install the library and just send it to doc file and have really cool visual looking report instead of copying and pasting for one software for the other software and so on. And if there are any changes, so you have to make numbering of the pages and so on, but you can have all the reports in one place.
Yeah, of course. You don't have to input these. You can export these results from structural analysis, and then you can run that for all the cross sections. So it's really about automating these tasks and in the same way getting these results. Again, we can do, and then you can input some. So say, hey, okay, it's good. We have sufficient capacity. If I exceed, say I just say 680. Then you can see, okay, we're outside, we don't have sufficient capacity. You can mark it with red to highlight that this is not okay.
Cool. Perfect. Like we have some questions that, is it possible to change spacing between bars? Of course, it's one of the
of course.
main functions.
Yeah, so in this case, for simplicity, I just wanted to give the user the option to just set the diameter of the bar. And then I'm using the minimum allowed spacings from the Eurocode to find as many bars as possible. But you could, in this function here, I think I even linked to the documentation. Yeah, you can see here.
We are going also to share this Jupyter with all the links so we can find it, and in your free time, just go through and study.
Yeah, so you can either set like the number of bars, and then you can define the spacing yourself and just calculate how many bars you have, or you can set the distance, which is what I did, just to make it easier for the user to input a number like that.
Cool. Okay, thank you very much, Sverre. We have lots of questions. I mark all of them, so I'm going to go to my presentation, short presentation, and show our work, what we are doing with Sverre. So thank you, Sverre, for your presentation. I will call you soon back for Q&A session. And the question for all of you, would you like to see how to learn Python if you work in the AEC industry, even without programming knowledge from before? So just write on the chat. Before we started, I asked a question. What is your level? I saw some -20, and I saw also some 2s and 3 and 4s. And if you are interested, so just please let me know on the chat. So I'm going to show you what we are working with Sverre. Martin is not today with us, who is also working on this project where we are teaching engineers how to program. So we can see Bjorn 3 and 10. Thanks for that comment. So I will go to my presentation and just show you how you can quickly start to learn programming. So I will jump to MindPoint. 1 week ago, together and with Sverre and Martin, we have opened second edition of programming in AEC industry. What is that? This is actually transformation into Engineer 4.0. So actually, this is a training program when we are transforming your engineering work into fun with programming. And This is in this training program, you will automate how to automate manual tasks in your project, how to use AI and get ready for all the revolution. I really like this quote from one of the engineers. AI can be a powerful multiplier for your engineering and programming skills. But if your skills are zero, multiplying them won't make any difference. So that's why we are encouraging all the engineers to start, even if the programming basic, because today we have ChatGPT, we have Copilot, that if you have basic understanding of code, you can really create lots of great automation. And the third thing that we are also encouraging to start a new exciting career path as a computational designer, where you are connecting your skills as engineers and also programming. So that's why, together with these two handsome gentlemen, Martin on the left and Sverre on the right, we have created this training program which consists of 3 trainings. I'm responsible for Grasshopper. Martin is responsible for C#, and Sverre, who you showed presentation today, is responsible for Grasshopper. For Python in Grasshopper Foundations. So what is the training program? We have already on the learning platform 3,000 engineers and architects, and we have a new approach for teaching because we are showing step-by-step approach. So usually when engineer want to learn Python, so start Googling it on the YouTube, and it's like, okay, there is some beginner intermediate Python in 6 hours, just watching these 6 hours, and that's it, and I know Python. Actually, it's not true. You have to be anchored in the AEC engineers. So that's why together with Sverre and Martin, we simplified all the process, and we transform it for the AEC industry needs. So actually we have 6 steps to learn programming. So actually we step from the computational thinking, where we teach how computers can solve problems. Then we are going to visual programming, which we think, and we are also doing that at the NTNU Norwegian University in Norway. We're starting with Grasshopper because it's a natural step to stepping inside programming, and in this case is Grasshopper. Next, step number 3, we are starting with Python or C# inside visual programming. We are not jumping inside Visual Studio because sometimes it can get just scared people, engineers, with the block of text. So that's why we are still working in the Grasshopper environmental. Next, number 4, we are jumping into Jupyter, Victor, Excel, and just using Python and C# in different environments. And finally, in the step number 5, we are in the Visual Studio or PyCharm. And next, we are into advanced programming with using all the software APIs like Tekla, Revit, Abacus, Global, and so on. So this is the whole path that we would like to take you together with us. And we have also approached learn by doing, not just watching tutorials. So we have programmed more than 500 exercises. It's a lot. We spent almost 2 years doing these 3 programs. So actually, we program everything in Grasshopper. And we make a kind of gamification. So actually you have to solve some exercises, like in this one. We are starting from really basic. If you are start to make a comments, you have to make a comments in the right place. You are getting points, and you are motivated to go to the next one. So I think it's a really game-changing how we are teaching. There are also some fun exercises like pattern findings and everything, what is most important, based on the AEC industry. So we have bridges, we have buildings, we have stadiums, we have piles for geotechnics, retaining walls, and so on. So when the program starts, it starts today. Actually, we opened registration 1 week ago, and all the Grasshopper fundamental modules are available right now, and the Python and C# modules are available also to start. And all the training is a self-paced training, and you will get the lifetime access to the platform. So you can start whenever you would like to, and even come back to materials even in the 1 or 3. So just to summarize what we have in the programming in ESE training, we have 60 hours of the video lessons. We have more than 500 practical exercises, homeworks, live session with trainers, and the closed Discord forum where you get support. And we have lots of bonus. And most important, there's zero risk. So if you would like to join, you have 30 days to get 100% refund. So our goal is your satisfaction. So if you will be not satisfied with our way of teaching programming in ESE, so you can get refund. Normally, this program is priced in Norway. If we're going to sell it, it will be about 3,000 euros. But we know that this price it's scary for all the markets. So that's why we have decided that these free programs and lifetime access will be 891 euros. So if you think it's to divide it into days of studying, so it's just 5 euros of studying. But the thing is that offer is valid until the 28th of November. So this is our offer. And I know that today we have lots of Python interested people. So that's why we have prepared a special promotion. I'm responsible for the Grasshopper fundamentals, and Sfere that you are seeing. So today is responsible for Python in the ESE fundamentals. So if you would like to join this 2 package, and we recommend if you are new to programming to start with this package. So for everyone who is watching this workshop with the promotion code using black24_workshop can reduce the price. So this is all for me. I hope that will be sounds really interesting for you. For those who are interested, you have questions, so we can answer. You can also find me on LinkedIn or just write an emails. And yeah, we have time to make a Q&A session. So in short, I will ask guys to come back. Let me see if I have. So I will share the links. So for those who are interested, please join Programming in ESE. You will find all the information. Do we have to buy Grasshopper additionally? No, if you are not interested in Grasshopper, so there is no need to enter that training. Yeah, this is all simple steps and all the guidance. So we are trying to really start from zero. Okay, so for those who are interested, please visit our webpage, and let's come back to the Q&A session. So let's go. This is the next step. Let's come back with Morten, and let's come back with Sfere. Hello, guys. Hello back. Let's go to some questions from before. Let's start with this one. Maybe I will change a little bit the view. Let's go to Q&A session here, Mark. Okay, is it compatible with the other softwares like robot structure analysis, SolidWorks, or Drupal? Do you have some experience? What is the aim of the StructuralCodes applying to other softwares?
That's a good question, and I mean, as long as this other software uses a Python implementation, and the version is between 3.8 and 3.12, it should be no problem. So StructuralCodes has some third-party dependencies that are explicitly listed, and also they are installed when you pip install StructuralCodes. So if you're able to install this in that environment, then you should be good to go. But yeah, due to the dependencies, we require a CPython environment. So for example, an IronPython environment will not work.
Yeah, but we have also Grasshopper. So actually with Drupal robot structure analysis, you have connection with Grasshopper. So actually, if you have this connection, so actually you can do everything through Grasshopper. So that's why we also recommend like using Grasshopper, because in our opinion, is becoming a hub where you can have your center module and just connecting with different software, and like your package library can just make an additional value. Sfere, some question to you. What do you think about Jupyter versus Google Colab for sharing scripts?
Do you hear me now? The sound is back.
Yeah, sure. Loud and clearly.
Okay, I have this low battery thing. I have to change it. Yeah, I think if you're just going to share it, I find when I'm sharing scripts, if there's for no one who's used any of these before, Google Colab is easier because you can just share the link and they can just enter it. And then you just need a Google account and it's you're up and running. But for working in, I like Jupyter. I feel like you have better control there. Another benefit of Google Colab though is that you can link it with, if you have an online drive, you can just link it to that. You can import your files there. But generally, just for beginners, I would recommend Colab. I use it for my students. It's a lot easier. They don't have to download Jupyter, run it from the computer.
Yeah.
It's just working straight out of the box.
Grasshopper can be run without Rhino. No, Grasshopper is a plugin to Rhino, so you need Rhino to that. If you are new to Rhino, so you can get 90 days free license. For our students who are joining our Grasshopper, Python, or C# trainings, we are also trying to fix educational versions. So just contact us for that one. Are there a lot of difference between Python and C#? Oh, this is most common question. We had a 2.5-hour workshop together with Martin and Sverre, like a battle between Python and C#. It's not easy to answer. Like basically, it's two different languages, but Python is much easier. And just to take it in bottom, I know this is a long story, but to take long story short, Python is easier to learn, but C# is more powerful. But do not take this discussion further, because I know that here, even in this room, we have some Python and C# lovers. So I know that, I don't know, Morten, are you a Python lover or C#? Like,
well, for me, that's kind of not that's not my angle to it.
Yeah.
I'm not familiar with C#,
okay.
But I know that C# is useful for its purposes. I know how to use Python. I also know how to use Fortran, for example. But I won't use Fortran for what I'm doing here in StructuralCodes, but I'm using Fortran for other stuff. So I mean, they all fit each other's purpose.
Correct. And this was also our conclusion on the end of the workshop, that you can use both and for two different purposes. Morten, question to you. Are you already working on integrating the challenges that will come with the new version of Eurocode 2?
Yes.
That's clear. That's clear answer. I really like it.
I can elaborate on it. You can have a look at the open pull requests, and you will see that we have a lot of stuff coming in there.
That's great to see that you are following on that one. Let me see. Come on. Hello, Liam. Is there a tool that can calculate the needed reinforcement? Let's just say longitudinal, when given the moments and the actual forces. Like, can the program calculate optimal rebars, mix, or bar size? Morten?
That's a good question. Well, what you can do, you can calculate the moment capacity given an axial force and the reinforcement layout. If you can do that, you can also iteratively update the reinforcement to get a capacity that's sufficient to handle your forces and moments. So basically, that's the way to go.
Cool.
In the long run, maybe we can look at implementing wrapper functions around this to be able to design reinforcement amounts.
To Sverre, I think a question. If I want to create my own components on Grasshopper, do I need programming, or these are tools for it?
I would say you need programming, yeah. So if you write, the components are written in C#, so you would normally write them in C# if you want to write native Grasshopper.
There are some components that are written in Python, but I think it's like 2%, like the whole ladybug.
Yeah, and you can write your own plugins in Python and Rhino as well. But C# is easier.
It's easier, and it's much faster and reliable when it comes to components for Grasshopper. Let me see. Hello, I'm an architect. I predominantly use Rhino plus Grasshopper plus Blender for Archi modeling and visualization. I want to learn Python, C++. I would like to know where your course will be useful to me. So if you already know Rhino and Grasshopper, so you don't have to go through Grasshopper fundamentals, we really recommend to check out Python and C# agenda. On the website, you can find the agenda for these two trainings. We have created a training for engineers and architects. Sfera and Marcin are structure engineers, but also working with architects. So you will learn Python in Grasshopper environment, but we are also going outside it. So yeah, definitely it will be helpful because we are also going outside Grasshopper. Showing connection with Revit, how to access API to Tekla. For example, you are showing Jupyter and going to Karamba for structure analysis. So there is lots of stuff. So we can go to programminginesc.com and check out the agenda here. Let me see, Kostas. I already have the calculated value for MXX, MYY, and normal force, but I would like to ask how I can create a 3D failure surface with these data points using Python. Any suggestion and libraries?
Yeah, I would go for matplotlib or plotly and use the 3D plot functions. I don't have the API readily available in my head, but yeah, there's possibilities there. The co-convener Diego in the task group, he's using matplotlib to calculate or to visualize in 3D the NMM interaction domain.
Yeah, sure.
Plotly, you can even have like this. You can interact with the plot as well, which is
sure.
Nice.
That's
super nice. You can have interactive plots that you can hover and yeah.
And this is one comment that I would like to show, and I think it's also the aim of this whole webinar workshop to inspire you. And from Capone, first and foremost, great job with the library. How did you get the idea, Morten, and where did you get fundings for such development? I think that a question if someone else would like to make a similar library. So what was your road path?
I think from my view, I've experienced later that there are other similar initiatives as well. So it's not that unique, but I mean, the idea came when it came to me at least when I prepared for that keynote in 2022. So I kind of saw that there's a couple of missing pieces in the AEC industry. So that's where my challenge to the FIB came from. But then the FIB kind of challenged back, and David, the Secretary General, he quickly assembled a team, which he asked me to lead. And from there, we kind of just explored the space. And it's a group effort, really. This is not a one-man show at all. So if you have an idea, you come so much further if you're in a team that you can develop with. So lots of credits also to the rest of the group there, and to the FIB for supporting it, kind of and backing it up and providing the context for this. And then you're asking for the funding. Well, I can only speak for myself. I do this as part of my position at NTNU. So the part-time position as adjunct associate professor at NTNU. The co-convener, Diego Toledo, he also does that as part of his position at the university in Venezia. I guess the other contributors has similar ways of dealing with this as well.
Yeah.
But there's no kind of direct funding. It isn't.
Yeah. Sfera, I think it was a question from Donatas when you were showing cross-section in Grasshopper. If there would be a data tree with different cross-section, would it work if you connect like hundreds of cross-section with hundreds of reinforcement? Would it still work?
Yeah, as long as you as long as you convert those data trees into you have to convert the nested arrays in or lists in Python. But as long as you do that, it will be fine. No problem. That's the strength
because because we don't have data trees in Python, so we have this nested list. So you have to convert it. But yeah, the whole idea is not just to, and I think we also just this different mindset that it's not just about calculating one cross-section profile. It's like cross-section all the profiles on your project. So when you obtain that, so actually it's really game changing.
But it's all about bookkeeping, right, Sverre? So it's totally manageable.
Yeah, and document through code. That's
sure.
What about pre-stressed elements? Are they in the plan?
Yes.
Cool. I like these answers. Is PyCharm a good option for development environment?
Of course, yeah.
But it's paid,
and
right?
As noticed in the chat here, it's not a free, but you kind of need to pay for it. So, but I mean, they are equivalent when it comes to features, I think. And you always see this when you see polls, they are 50-50 almost. And you have a small outlier for Vim, for example, but then the big ones, they are PyCharm and VS Code.
I think this question already was answered. Is there any function for circular share check?
That's a really good question, because in transfer share design, you often relate to, equivalent rectangular sections. So basically, you would need to kind of find out what this equivalent rectangular section is. So out of the box, we didn't implement that yet, but I see some possibilities. So we'll definitely explore that.
Cool. Vladimir, sorry, but I do not understand. Do I need Grasshopper? Can I learn just Python AEC? Of course, you can just jump in the Python training, but it's our recommendation to start from the beginning. If you are new to programming, if the new programming word is something new to you, so we really recommend to start with Grasshopper because it's a visual programming language and it's easier to start, grasp the understanding of lists, data structure, data types, and then start to Python. Of course, you can just start with Python, you can start with the C#, but the main thing is that you have to use it at your work and maintain it. It's not just you are going to use for one thing, and Grasshopper gives this possibility to work with your software. If you are working with finite element software, for sure Grasshopper has connection. If you are working with Revit, if you are working with Tekla or Archicad, so we can maintain and train that, because it's not that you are going to make 60 hours training if you are not going to use at work. You have to use Python at work, and that's why we really recommend to start with Grasshopper first, to use it at work, and then start to learn Python. Let me see. For Liam, do you think programming is critical since AI has come to play? Also, since the guests work as the structure engineers, can they give us example on how they use Python instead of software available like ETABS? Sverre, would you like to start? Are you afraid of AI or?
No, not yet. No, I see it as a helper, as a tool to work more effectively so far. But does Python replacing or AI replacing everything in the near future? I don't think so. Not for the majority, at least. I think there will still be a need for a regular finite element software, as we're accustomed to. But the ability to create pipelines using Python, I think, becomes more important when we need to work more effectively, save some time there. And then, of course, if you take away those boring export-import tasks, then you can have more time of solving the engineering problem at hand, which is, after all, I believe, the fun part of our work.
I'll automate all the boring and focus on the really engineering. What is your experience with AI, Morten?
I think that a kind of a quite crucial aspect of the structural engineering profession is the creative aspect of it, and I find it quite hard to replace that creative aspect with artificial intelligence. Although I can see some use of it. Well, for example, if you are coding, it could be a useful tool for code reviews. But I mean, it could also assist in getting started. But I mean, even coding is kind of a creative task. So in the end, you need to spend time to develop the skill and make it kind of an extra finger, so to say. Develop your own toolbox and your own understanding.
Cool. Thank you for sharing your experience. We have someone who joined just the training, hopefully can access the full course of the Python and C# soon enough, as now only introductory course. So yeah, we are going to implement with every edition new bonus materials. That's Sverre and Martin, so it will be more and more advanced. Sverre, I think it will be a good question to you. What is the advantage writing code versus Excel formulas? Like, we know that AutoCAD and Excel are the most used softwares in the AEC industry. So what will be the benefits of using Excel?
Of using Excel or Python?
I was just joking. Like, yeah, of course, writing a script in Python. For those who don't know, it's also from last year. It's possible to import all the libraries into Excel.
Oh, sorry.
Yeah.
No, for me, the code is just easier, faster. It's more transparent. I don't know if you try to look up like these functions, searching through a lot of rows in Excel. It can take a lot of time if you have different documents. And in Python, for me, in Python at least, it's just faster, easier to see what you have, easier to visualize, combine the different. Like say you have pandas as an alternative to Excel. It's just much easier to keep a track of your work.
Cool.
I mean, it's hard to describe if you haven't tried it, but as soon as you get used to Python, for me at least, there's no going back to Excel for those large data sets.
You can also add to that if you're coding, you can also immediately use Git and GitHub for version control and for code distribution, which really adds superpowers to this.
Morten, with some question to you and your work with the structural codes, is there any plan for version for American codes or other codes, like name it, Australian, Asian?
I can be short again. Yes. So we have James O'Reilly from Vancouver. He's currently exploring how to adapt to the American code. I'm really looking forward to seeing his progress there. Well, that's kind of the code that we're exploring for the moment, in addition to the new Eurocode 2 and the new FIB Mold Code 2020.
Perfect. I love that all the work is already ongoing, and it's just a matter of time. So do not wait. As Sverre said it, it's really great to be one of the first adapters, and actually it can be also huge benefits for company and for self-developing the career, like being one of the first creating.
Let me emphasize as related to that question. Well, if there's a code that you're looking for, please reach out. If there's a code that I'm not used to, perhaps you're used to it, perhaps you can contribute code related to that design code. We are all relying on contributions from the community, so please reach out and let's see how we can manage.
Yeah, let's continue about this Eurocodes topic. What about all the adaptation for the, let's say, appendings for the national Eurocodes? How you manage that? You said that there was Norway, Spain, Italy involved. Is it also national appendings?
That's a really good question. So in every country in Europe, you have every country has their own national annex with nationally decided parameters. So related to, for example, structural safety. That's up to each and every national body. So for the moment, we have not yet implemented the different national annexes, but we have implemented a backdoor for it. So we have a plan for how to deal with it. We just haven't dealt with it yet.
Cool. Any advices how to create Autodesk Robot API using Python? Is it possible? We tried that together with Marcin. Marcin, who is a teacher on the C# training, and it's possible. Robot is made in the C#, so it's made. And actually, he's going to record one of the bonus modules about how to connect to Robot API, but it's about using C#. Let me see. I will scroll down. There are some more questions. We have still 5 minutes to go. Can we see an example of the reports you created? The Python coding is not super complicated, but I never see great examples of the final output. Sverre, so are you going to share this code?
Yeah, I will share it. Probably after Friday. I don't have that much time to clean it up, but we will share it.
Yeah. When we install the Python through virtual environment, do we have to install again if we want to use it again next time?
That's a good question. If you first initialize your virtual environment, just as we did, then activate it, then install libraries within that environment, they're all kept inside the environment. So next time when you activate, then reactivate your virtual environment, all the libraries that you installed in it will be available for you.
Perfect. Sverre, can we use Visual Studio Code to work on pandas like Panda Power? Have you tested?
I don't know what Panda Power is, but if you mean, Morten, you heard of Panda Power?
No.
But if he means like the package, yeah, definitely you can.
Yeah, if it's available package, so for
package,
sure.
Yeah.
Sure. So reports are built in PDF or in the text editor format. So actually, you can decide it. There is a additional library, so we can export it to doc file. We can also make it in PDF. So actually, there is no
even LaTeX.
Yeah.
Let me add to that, Chris. I would advise you to go to mystmd, so mystmd.org. They have some really good examples and tutorials for how to get started using Myst Markdown. So basically, then you have some LaTeX on the back end, and you can write your report in a Jupyter notebook. You can embed figures from Matplotlib, just as Sverre demonstrated. You can spin up a local static web page with your, like you have it there. So you can spin up a static web page with your content. And then when you're satisfied with the content, you can export to a docx or a PDF. This is a really, really powerful tool that is being evolved these days. So it's in rapid development.
Do you know if it works with the HTML output or CSS code? Do you know that?
Sorry, I didn't get that.
Can Myst work with HTML output or CSS code?
Oh, do you mean? Well, there's kind of an order how this is parsed. So I'm not sure whether it's parsed first to HTML and then later to LaTeX. I don't know.
Okay, let's just wrap our presentation. Thank you guys for being together with us. I think it was great presentation. For those interested in our training, there is still a possibility to join until the Thursday. We really encourage you to join it, and we really encourage to download from GitHub StructuralCodes, which are available for free. And don't forget to leave the star there. There is a great project done for Morten. And yeah, would you like to wrap up at the end, Morten? Maybe encourage some engineers to try different methods of working?
Yeah, really. I would encourage you to explore the StructuralCodes library. So try it, head over to our docs, look at our quick start example, see if you get it working, and explore the API for the design codes. I guess you'll find some useful stuff in there. And I would also like to emphasize that this is a group effort. So thanks to the whole task group, and especially to the FIB with Secretary General for supporting this.
Yeah, and Sverre, some closing for you who was not in the creator group. So it's maybe for easier just to say that is it useful or not. We know like Morten was in the creator, so he cannot just come in the webinar and say yes, use it because it's useful, because he spends a lot of his free time on that. What is from you as a structure engineer perspective using StructuralCode? Is it game changing? Is it something new, or is like a new additional library? What is your opinion on that?
I would say it's like a new tool to my toolbox. So I see the potential of this being very useful in creating reports, and I also have this, and even before Morten introduced this, and I was familiar with this idea of being able to hopefully using these kind of open source Python list to replace some of those license documentation tools that we already have in a lot of, at least in Norway, consulting firms that we pay a lot of money for, which doesn't seem like they've been happening any development on them for the last 20 years, but we use them every day. And I really believe that initiatives such as these can help us customize our own documentation and report tools. So I'm really looking forward to see how this goes.
Yeah, thank you. We have lots of great comments. Thank you for the presentation. Good effort. So it looks like a great job. We tried to answer all of your questions. We haven't ignored your question. I checked your question, like for example, that one about Eurocode 3. We answered that we were talking about concrete this time, but maybe Morten, some comments on Eurocode 3?
Yeah, sure. Well, actually, we do have implemented some sections already. So you can, from StructuralCodes.geometry, I guess you can import a set of different steel sections. And as I mentioned, the initiative comes from the FIB, so we have a concrete focus for the moment. But I think the framework also could fit to Eurocode 3. So please, if you see the fit, reach out and we can see where to head from here.
Perfect. Thank you. Thank you very much. We have some still questions. I'm trying to answer that, and together with Sverre, maybe if some are question, Morten and Sverre are on LinkedIn, also in the mail, and also share the GitHub repo. Okay, thank you again very much. It was a pleasure to host this workshop. And Morten, good luck with all the implementation. I see that you are in the track. And yeah, maybe with me and Sverre, you are going to see us on the learning platform. So that's all. Thank you very much. Bye-bye.
Bye.
See you. Bye. Thanks.